Hey everybody, my name is Rachel Steffen. I am a second-year PhD student in Dr. Mandy Joy's lab. I'm studying sources and sinks of methane in Arctic and subarctic marine environments. I am also social chair for our Marine Science Graduate Student Association. A little about me, I graduated from Washington and Lee University in 2018, where I ran Division III cross country and track. I majored in biology and minored in German. I was extremely fortunate to be able to get involved in several research opportunities while I was an undergrad. I interned with the Navy's Marine Mammal Program and got to work with the Navy's dolphins. At WNL, I studied the range limiting factors of salamanders in the Blue Ridge Mountains. And I worked with one of my professors studying the effects of bison grazing on the nutrient cycle of the grasslands in Yellowstone National Park. So that was really cool because we got to work with the National Park Service, but I also had to collect a lot of bison poop, so some pros and cons. In between my junior year and senior year, I got to work at the Virginia Institute of Marine Sciences Eastern Shore Lab and assisted a grad student who was studying shark physiology and their response to climate change. And then I got to present some of this research at the Tidewater chapter of the American Fisheries Society Conference, which was a great experience. I kind of took all the things that I had learned from these experiences about nutrient cycling and ecology and the impacts of climate change and decided to pursue a career in marine biogeochemistry. So after I graduated from Washington Lee, I came down to Skidaway and worked as a lab technician and researched the uptake of different phosphate sources by model phytoplankton species. And that led me to apply to Mandy's lab. So then I moved up to Athens in the fall of 2019. My current research is focused on the methane budget in Arctic and subarctic systems. Permafrost is defined as the ground that's been frozen for 2 or more years, sometimes up to hundreds of thousands of years. It lies beneath the active layer of sediment in the tundra and beneath the coastal ocean along continental shelves in the Arctic and subarctic. Along with the subsea permafrost, there are methane hydrates, which are frozen lattices of methane and water that are submerged along the continental shelves as well. And the Arctic is warming 2 times faster than any other region on Earth, which leads to this permafrost melting and thawing and gas hydrates dissociating, both of which are currently acting as methane reservoirs. So as they thaw, they release methane into the atmosphere, groundwater, rivers, runoff, and coastal marine waters. The picture on the slide is actually of an Arctic lake, and all those frozen bubbles are actually frozen methane bubbles. And methane is super important to study because it's a very potent greenhouse gas. It's actually considered to be 28 times more potent than CO2 over a 100-year time frame. So an increase in methane into the atmosphere will lead to significantly faster rates of warming, thus releasing even more methane, and this is what we refer to as the methane feedback loop. Luckily, there are methane oxidizing bacteria that live in the upper water column and also in anoxic sediments, and they consume methane. But the question is, at what rate will it keep pace with increased methane sources? So in addition to permafrost and gas hydrates, there are a number of internal and external methane sources that must be accounted for to understand this full methane budget. The overall dynamics of the whole system are changing. For example, in addition to methane, permafrost thaw releases organic matter and nutrients, and the warming increases river discharge. There's less ice, which leads to more primary production. So it's important that all these factors get taken into consideration when looking at this balance of methane production and methane consumption. The goal of my research is to evaluate and quantify the magnitude of methane sources and sinks to provide the information needed for evaluating global methane budgets and hopefully be able to guide the development of more accurate climate change models. Currently, I'm preparing for a study in Placentia Bay over the 8-week spring bloom period. And this will provide me the opportunity to look at a coastal estuary system influenced by a lot of rivers and runoff. And then over the summer, I'll hopefully be able to go on a cruise into the Labrador Sea, which will provide me with data from more of an open ocean environment. So I'll be able to look at methane oxidation rates and methane production rates and the amount of methane and nutrients coming from river discharge. So I'm really excited to be able to get the opportunity to go to these places. So why did I choose UGA? As you can probably gather from watching all these videos, there are some truly incredible people and research to get involved with here in the department. And I've also really appreciated how much I've gotten to collaborate with other labs and universities. So during my time at SCIO and then as a student in Athens, I've gotten to work with Georgia Tech, University of Michigan, Columbia University, and Memorial University up in Canada. I also decided to go to UGA not only for the research, but also because of the incredible community here. There's some truly brilliant minds in this department, and I've got to make some incredible friends that not only brighten my day, but have also made me a better scientist. The final reason you should come here is to take our totally awesome scientific diving class in the pool that we have in the basement. It's a combined class with grad students and undergrads, so you get to meet a lot of people. We take a trip down to Florida to get our diving certifications, and it's just a really great time. So 10 out of 10 would recommend. And finally, the proximity to Atlanta is really nice as well. Athens is such a fun town, but if you're looking for bigger city vibes or big events going on, we're only an hour and 10 minutes away from Atlanta. So you can see in this picture here, I actually got to go watch the US Olympic marathon trials this last year, which was such a cool experience.